Welcome to Bite-Size Data Science. There is one more thing I want to cover related to text processing. It relates to two terms you may have heard, word-to-vec and word embedding. This relates to converting words to vectors of numbers. The vector size varies, but is often between 100 and 1000. To create these vectors, a model is trained on a set of documents or corpus. The first step is to encode each word into a one-hot vector. So, if you have 10,000 different words, each word used as the input to the model would be a vector of size 10,000. The basic idea is to find a word based on a few words surrounding it. Aesop said, "A man is known by the company he keeps." In our case, a word is known by the company it keeps. The creation of the model is non-supervised. Documents are fed to the model, and the result is the encoding. Since the resulting vectors are based on statistics, the quality of the result depends on the quality and size of the input. The corpus to analyze tweets would be different from more traditional text. Let's see what we can do with these vectors. I'm using a Jupyter notebook in the IBM Watson Studio environment. Take a look at the description below the video for the URL to create a free account on that platform. The description also includes URLs for the notebook I'm using here. I am using word vectors already created by Stanford University called GloVe. I am also using a Python library called GenSim to do high-level operations on words. After loading the data, I now have 400,000 words with word vectors of size 100. The first thing we want to do is look at word similarities. Here we see that the highest score is 1.0. Good and best have a similarity index of 0.805245 and bad compared at 0.77028. Then, compared to mouse, we get 0.267857. So, bad may be an antonym to good, but it is used in similar manners. This explains the relatively high score in the comparison. Which are the words closest to Spain? GenSim returns the top 10 values for a word. It makes sense. The results are also countries, except for Spanish. I'm sure we can agree that Spanish is close to Spain. Doing the same thing for Canada also returns countries, but we see Zealand instead of New Zealand, and we see United, State, and USA instead of potentially saying two choices instead of three. We could argue that it should be one choice. Of course, this depends on the training data. A word like although provides good choices with however. I was surprised to see though as the second choice, but a quick search for the definition gave me despite the fact that although. So it is definitively a very similar word. Finally, the word computer shows related words. It makes sense that we'll see those words in similar context. We can take these word vectors one step further and do algebra on them. We see here what we get when we subtract man from king and add woman. In this case, our closest answer is queen. Building on this, we can look at analogies. The first one is Paris is to France what something is to Rome. This is equivalent to France minus Paris plus Rome. We see that the first choice is Italy with a decent margin from the second place. The results are pretty good, but we can't expect perfection. You can come up with all sorts of analogies. You are bound to find mistakes. Since words can have multiple meanings, it complicates things. GenSim has a function that extracts the least likely match in a list of words. Here we see that breakfast, cereal, dinner, and lunch return cereal as the odd man out. Looking at the similarity between words, it is easy to understand. To conclude, I want to show some code to visualize a grouping. To reduce the number of dimensions, I'm using TSNE, or T-Distributed Stochastic Neighbor Embedding. Obviously, the number of words displayed and the graphic size make a difference in how much information we can get out of it. In this video, we saw that words can be converted to numerical vector that include context information of the words. Word embedding is yet another tool in your arsenal for text processing. See you next time on Bite-Sized Data Science, and don't forget to subscribe.